welcome to the penultimate video in my series on producing robust programs. Today we're going to be looking at different forms of testing. So the purpose of testing is to ensure that programs function as expected. It is essential to find situations that could impact on the function, usability, and maintainability of the program. We're going to look at two types of testing in a great deal of detail. We're going to look at iterative testing and final testing. Iterative testing is testing during the development of the program, whereas final testing is testing after the program is finished. So let's start with iterative testing. This is often referred to as Whitebox testing. This involves testing the program while it is being developed. Programs are checked at a modular level during development. So this diagram here is pretty useful in understanding that. You write a block of code and then you test it. Then you write another block of code and then you test it. So every time you create a new subroutine, every time you create a function, a procedure, a block of code like a for loop, you test it, check that it works. As each new module is added, the program is tested to ensure that no errors have been introduced and data from previous modules works with the new module. This is why we've referred to it as a form of whitebox testing, because you actually have to understand and look at each part of the code. And all these need to be tested to make sure that they work and that they work in conjunction with all the other modules of code that you've created. Again, iterative testing is an example of whitebox testing. The advantage of this sort of testing approach is that if the test fails, whitebox testing allows you to quickly pinpoint the source of the error. So if you're testing a new function and there's an error, it's probably an error in that function. You can find it, locate it, fix it really quickly. Disadvantage, it can take a long time to run through all the test data. Especially if you're testing each section as you go along, it can be quite time consuming. Moving on, we're going to look at what we call final or terminal testing. This is a form of black box testing as opposed to iterative testing, which is a form of white box testing. Final testing involves testing that the final program functions as expected. It checks that the modules are all correctly assembled into a working solution, checks that the program produces the desired results using real data and a typical end user. So with black box testing, all the code is hopefully finished, you input data, and you check that you get the expected result. Testers in this sort of testing ignore how the program works and simply enter the inputs and check if the output matches expectations. The advantage for this is that it's fast to carry out. The people doing the testings don't need to be expert programmers. They don't need to know about the code. Disadvantage, if a test fails, the tester does not know why it failed. It's not producing the desired output. We need to send this back and we need to get the programmers to look at it again and try and work out what the error is and try and fix it. So if we compare white box and black box testing, this helpful little diagram, you can see with black box testing, you're just inputting data and checking if you get the desired output. It is just a black box in the middle of the code. You don't know about it. You don't know how it works. You just want to find out if you're getting the right result. But with white box testing, you need to know how each section of the code works. You see what's inside the code. You see what's inside this box. Next, we're going to take a look at user acceptance testing. So this kind of follows on from your kind of final black box testing. This involves seeing how the program works for a real or simulated user. We're going to look at what we call alpha testing and beta testing, which you may have heard of. Alpha testing is simulated or actual operational testing by an independent test team at the developer site. So this means getting somebody who's not part of that software development team who's been working on this program to actually do the testing, because they're going to use it differently and maybe find errors and mistakes and usability problems that the software development team might miss. Beta testing is when versions of the software known as beta versions are released to a limited audience outside of the programming team, and these are known as beta testers. This software is released to groups of people so that further testing can ensure that the product has few faults or bugs. So an example of this might be, okay, you've designed a new package for an accountancy firm. You get some of their accountants to test your software, either on your site or their site, and see if it works the way that it's expected. Because again, these are real users. They're going to use it differently than an expert user. They're going to click on things differently, enter data in the wrong way, and you're going to find out how robust your program is. You've also got the idea that beta versions can be made available to the open public to increase the feedback. So with big software products, sometimes this is the best way to do beta testing. You can let anybody download the program, for example, productivity software or even a computer game, and they can test it with the knowledge that it is a beta version. There's still going to be bugs, there could still be mistakes, and you can collect all these data from all these beta versions that people are running, all these beta testers that are free testers for your product, and collate those together and hopefully fix the main bugs before you make a final release version. So I think that's enough about testing from me. I'm going to do one more video in this series shortly, and that's going to be looking at test data. Hopefully you'll join me for that.